Hello everyone, welcome back to the Aspen Tech channel, and in our today's video we will be simulating the ethyl chloride production using Aspen Plus. So before going to the Aspen to solve it, let's look at the process flow diagram that how this process is produced generally. So this process starts with this mixer, which is mixer number 1 in our case, and this feed, which is labeled as F1, is entered in the mixer. The purpose of adding this mixer is to ensure that once we recycle the stream, there are no problems in the infrastructure or the design of the system. Then this mixed stream, initially it will be only one stream, but after the recycle it will be the mixed stream. It will be sent to this reactor. For the simplification, we are assuming a stoichiometric reactor in Aspen Plus. Then product will go to this compressor. It will be compressed, then cool down and is separated in this separator, which is SEP, and top product and bottom product are produced as F6 and F7 respectively. The F7 stream is sent to this distillation column, where this F9, which is 99.9% pure ethyl chloride, is produced or separated, and the top product and this one, the F6 and F8, are mixed. Then part of it is purged while remaining is recycled. And how it is recycled? By passing through a valve and heating the mixture or F13 to that of the feed temperature, or the conditions are similar to that of the feed conditions. So that is the overall schematic of how to produce ethyl chloride using ethylene and hydrogen chloride. This is our main reaction in the system, that 1 mole of ethylene reacts with 1 mole of HCl to produce ethyl chloride C2H5Cl is its chemical formula. So the feed condition is that temperature is equal to 25 degrees centigrade, pressure 2 bar, flow rate 1000 kg mole per hour. The composition of ethylene is 0.48, hydrogen chloride is 0.5, and nitrogen is 0.02 in the feed. So these are labeled as E, H, and N. Then the reaction is ethylene reacts with HCl to produce ethyl chloride. 90% conversion of ethylene, 0.1 bar pressure drop in the reactor. Then compressor outlet pressure is 21 bar. In the cooler, as we know, its degree of freedom is 2. Outlet temperature is equal to 20 degrees centigrade. Pressure is equal to minus 0.1 bar. Then in separator, temperature is 20 degrees centigrade. Pressure is 0 bar. The heater, same specifications of temperature and pressure as that of the feed. Then in distillation, there are 7 number of stages. Feed stage is 4. Condenser type is partial vapor. The flux ratio given is 1. Percent purity of ethyl chloride in bottoms is 99.9%. And pressure of the column is 19 bar. It means the condenser and reboiler pressure will be 19 bar respectively. Then in split, mole fraction of purge is 0.1 and the outlet pressure from the valve will be 2.5 bar. So let's move to Aspen Plus and simulate this overall process. So at first we will add the components. And what are these components? C2H4, which is ethylene, HCl, which is hydrogen chloride, C2H5Cl, ethyl chloride, and 2 nitrogen, and we can say it as E, we can label it as H, we can label it as EC, and this one is N. Nomenclature is obviously up to you, as we have discussed various time before. And then clicking on next, selecting property packages Peng-Robinson, click on next, and then run this. And once results are available, go to the simulation environment. We will first draw the flow sheet, or we can simply attach one equipment one by one and simulate it. So first it's a mixer, which is mixer 1 in our case, and there are 2 feed streams, but for now we will attach only one feed stream, and that is the product stream, and we will simply control A, control B to align it. Now specify feed, and that is 25 degrees centigrade, 2 bar, 1000 kg mole per hour, and mole fraction is 0.4 for ethylene, 0.5 for hydrogen chloride, 0 for EC, which is ethylene chloride, and 0.02 for nitrogen, and total mole fraction is 1. And obviously this V1 is solved obviously. Then click on this reactors, stoichiometric reactor B2, and again connecting it of reactants and products, and again control A, control B. And what are the specifications? 25 degrees centigrade with a pressure drop of 0.1 bar. Then in the reactions, click on this new, and the reaction is that ethylene reacts with hydrogen chloride to produce ethylene chloride, and the coefficient for reactants is -1 as converted, and 0.9 of ethylene in the process. Then after specifying these two, we need a compressor in the system. So this is a compressor, and it has been attached over here, and again doing the connections. And now giving the outlet pressure of isentropic pressure as 21 bar as we have been given in the problem statement, and we know the block for heater and cooler is same in Aspen Plus while it is different in Aspen HYSYS. So again doing the connections over here and in the same way, and this one is 20 degrees centigrade with a pressure drop of 0.1 bar. Then the separator in the system, and this F flash 2 will be used as a separator for the process, and it will be connected here. This one is the top product, this one is the bottom product in the system, and the conditions are same as that of the cooler outlet. So 20 degrees centigrade and 0 bar, and that 0 means that no pressure drop in the system. And after that this F7 will go to this distillation column, which is red flag in our process main distillation column, and the outlets are full reflux in case of Aspen HYSYS and partial vapor in case of Aspen Plus. And then clicking on this, and total number of stages are 7. Condenser type is partial vapor, rest will remain the same. Distillate rate temporary we will assume 100 kmol per hour. The flux ratio of 1 as it has been given in the problem statement. Obviously we need to vary that operating specification of distillate rate because it is not given as fixed. We need 99.9% purity of ethyl chloride in the system. So clicking on the stream, there are 4 number of stages. The pressure, if we specify as stage number 1 as 19 bar, it means throughout the column it will be 19 bar unless we specify any pressure drop here. So this has been converged as well. Then clicking on this mixer, which is mixer number 2 in the process, and connecting F6 and F8 to it, and if we align it like this, which is F8 and F6 in the process, and the outlet is obviously F9, and again it is solved. Then clicking on the splitter, and now it will be converted into 2 fractions, and that is one of them, which is F11 is purge stream, while the remaining the second stream will be the recycle stream. So click here, F11 is 0.1, means 10% of amount is purged while remaining will be recycled. Next one is the valve, and we click on this valve and connecting the inlets and outlet to it, and accordingly valve outlet is 2.5 bar. Then the heater connection will be given over here, and in exchangers this one is the heater, and clicking on it, rotate icon, flip horizontal to ensure proper connections, click here and then click here, and accordingly again aligning it, and the outlet conditions are same as that of the feed, that is 25 degrees centigrade and 2 bar. So for now this process or the overall schematic, if we look at it, is completed without recycle. So we can simply click on this run button and we can see if there is any error in the process. So the results are available. We can force the time check what is the percentage purity of F9 if it is 99.9% pure ethyl chloride or not. So in F9 it is 97.12% of ethyl chloride. So it means we can apply operating spec over here before going to the recycle. So going to this design specification, click on this new, and in this mole purity of 0.999 components of ethyl chloride and feed product F9, and vary, obviously we cannot vary the flux ratio because it is fixed in the process. So what we can vary the distillate rate. So let's assume it is 102, somewhat about 600 kmol per hour. So reset it and again run it to see what is the trend, is given condition is achieved or not. So it is achieved, and for verification we can go to the stream results and we can see again that in F9 it is now 99.9% pure ethyl chloride in the system. So now what we need to do after applying this design spec, we need to simply go here, and what we need to do, we need to connect this F14 with this mixer, and now we need to again, you can reset it, and now you can see the results are available after connecting this recycle stream, and it means that the process is overall converged. Obviously you can see the effect of this recycle on the duties of the system. Obviously once you have recycled, the compressor duty would have increased, the cooler duty would have increased, and obviously the heater duties would have been increased in the process, and accordingly the manipulations would have been carried out. But recycling the process obviously increases the efficiency of the system. So that's how the ethyl chloride process is simulated using Aspen Plus. That's it from this lecture. Thank you so much. Please do watch, like, share the video and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more videos.